Okay, today we're going to go over some notes on writing a function rule. Okay, we're talking about word problems today. So you guys have gotten pretty good at solving equations, plugging in the numbers. What if you don't have an equation? What if you read a word problem situation and you have to put together the equation from scratch, just based on what you read? That's what we're going to go into today. So we're going to start off by going into some of the most common vocabulary words and what they mean in math. Because all you're doing when you read a word problem is you're translating it into the language of math. Kind of like translating something from English to Spanish or something. You're going from English to math. So you guys probably know the word is usually means what in a word problem? If I said my cousin is 15, I'm saying my cousin equals 15 years, right? So is means equals. But also the word was and the word were, those also mean equals. So very often, nothing's 100%, but very often, looking at the context of a situation in a word problem, when you see is or was or were, you're looking at an equal sign. You guys know what plus means, right? What math operation is that? Addition, yeah. And some other ways to say addition in a word problem would be more than, sum, total, and even the word and. Okay? Like if I said something like, I had 5 bananas and George had 3 bananas. The word and, separating that, most likely you're going to add up those bananas. Okay? Miss Odom, did you guys come up with some other ones for addition? Oh, okay. Some other ones you might run across, maybe not as often, but there's all together. You can just write these kind of below there. There is increase. We already have more than, and more. We already have plus, sum, total. Another one you might see is combine. If you see the word combined in a word problem, there's a good likelihood that they're wanting you to add. What does minus mean mathematically? Subtract. Another way of saying subtract could be less than. And another one might be difference. What is the difference between, two different numbers? They're telling you to subtract. Some other ways of saying subtract could be decrease. You may have the word less and not less than, just like you could have more but not more than for adding. You could have fewer. You could have reduce. And so that covers probably most of them you usually see. So we've covered adding, we've covered subtraction, and now we're going to cover multiplying. Okay? We talked about the words that help you find the slope. We talked about the words per, each, and every. And all these words go right here because that means you're multiplying your slope and your independent variable. So the word per and each and the word every, which I'm going to write in right here, those all mean you're multiplying. Okay, I'm going to put a dot for multiply. But there's some special case words also. The word twice specifically means you're multiplying it by 2. The word double means you're multiplying it by 2. And the word triple means you're multiplying whatever the number is by 3. Okay, there's some other words for multiply. There's product. The word product means multiply in math. And you're not going to see quadruple too much, but what does quadruple mean? Times 4. That's times 4. Okay, I'm going to leave that up for a few seconds for you guys to get down. And what you might want to do, I encourage you guys, this part of your notes you're going to use a lot while you're doing word problems. You might take a picture of this part of your notes and have it on your phone, so when you're doing homework assignments really throughout the year, you can pull this up and as a quick reference, all right? I'm even going to use it as a reference for the rest of the notes. What I did is I I cut out the little paper, and we're going to refer to this as we go through these word problems. Okay, so if you don't have this, this part's going to stay on the screen as we do the word problems, all right? So, who wants to read number 1? Jasmine. Anybody?
Someone wants to purchase a new guitar. The guitar costs $800 each. She has saved $150 and plans on saving an additional $50 each week. Write an equation to determine the number of weeks W that it will take for Jasmine to save enough money to purchase the guitar.
Okay, so let's go ahead and go through some of these words that we have right here. Like, here's one. Jasmine wants to purchase a new guitar. Okay, great. The guitar costs $800. There's some math right here. The 800 is going to be in the equation. And this is a little template that they're giving us for this problem. A lot of these are going to have these templates for these notes. Okay? Then she has saved $150 and plans on saving an additional $50 each week. So you have two parts here. You have the $150. You have the word and, which our vocabulary says it often means adding, right? So you have the $150, and you're adding that to the amount of money she's saving each week. How much is that? $50 each week. This word each is another vocabulary word. The word each means multiply. Okay? What are we going to multiply? The $50 and the number of weeks. Right here. $50 times the number of weeks. Y'all see how the vocabulary is kind of helping us put everything together, all the little puzzle pieces? So $50 each week means you're multiplying the 50 times the number of weeks. This word and means you're adding that portion to the $150 she started with. Okay? So what is the price of the guitar? $800 is what she needs. Is means equals. You see how you can pull those little pieces out and dissect each one and get the meaning of each one based on the vocabulary, and you can piece them together and you get your equation. So that's our template. Let's go ahead and now write the equation out like you would without the template. $800, the money she needs, is equal to the $150 she started with plus $50 times the number of weeks she's saving it, because she's saving $50 every week. Make sense? Do you guys remember y equals mx plus b from last year? This is a y equals mx plus b pattern. It just has the mx on the other side. Okay? You're going to see that pattern a lot. It's not in every problem, but it is very common. Okay? Does that make sense? Some good news about what we're doing with this homework is we're not solving. You guys have done so much solving. You're probably pretty good at it right now. All we're working on right now is setting up the equation, and we move right on. Okay? So, number 2. Anybody want to read number 2? I'll give it a read. Okay, Reggie wants to buy a shirt that is on sale for 15% off the regular price. And the regular price, they're using the variable P. They want us to write an equation to find the amount of discount D that Reginald saved, and S, the sale price of the shirt. So let's go through and find the vocabulary. Okay, 15% off. Now this is something we didn't address at all with our vocabulary, percents. 15% off. What do you think the word off means? Are we adding, subtracting, multiplying, or dividing? You're subtracting. You might even add that to our subtracting list. The word off can often mean subtracting. Now, we're not taking $15 off. We're taking 15% off, and we'll get to that in a minute. Write an equation to find the amount of the discount that he saved, and S, the sale price. All right, so what else is important in here? The 15% is hugely important. The regular price is hugely important. We start with the regular price, and then we somehow figure out the sale price based on this, and we take that sale price away. All right, and what do we want? We want to find the discount. And then lastly, we want to find the sale price. So those are the important pieces of the word problem. Now notice, this is actually going to be two equation setups. Okay? They wanted us to use, and we're going to do this one first, the amount of the discount. How do we find the amount of the discount? They want to represent discount with the letter D. So D equals, because is means equals. How do we turn 15% into something we can use mathematically? We don't want to use a percent. How do you change it to a decimal? It actually is. You know what? 15 over 100 is correct. But that's kind of a fraction that's not so friendly. If you did 15 over 100 and you just did 15 divided by 100, what do you get? You get 0.15. So this is 0.15. And then the regular price is P. What kind of math is happening here? This is not subtraction here because we don't even have the money yet. Once we turn it into money, we subtract. How do you find 15% of the sale price? It's 0.15 times the sale price. I mean the regular price, not the sale price. So when you do 0.15 times that regular price, that changes the 15% into the actual money value that would be. Okay? So anytime you're at the store and something's 15%, you want to find out how much you're saving. If it says 15% off, you do 0.15 times the price that it's listed as, and that would be the money you take off of the price. Okay? So once we take that off, that's going to become our amount of the discount. Okay? Now that amount of the discount is going to go over here. Once you convert this into money, you're going to take away the money from the second equation. So sale price S equals the regular price, the same P that we used in the first equation, we're going to use in the second equation. Okay? So you have your regular price, and you just take away the amount of the discount that you calculated from the first equation. Okay? We're not going to get into specific numbers right now. We're just kind of getting you guys familiar with it. We're not going to do any solving. We don't even know what the regular price is for any of these items right now. We're just kind of getting the patterns together. So we're going to write both equations here. How would you find the discount? You would multiply 0.15 times the regular price. And then once you have that number, you'd get your new price, your sale price, by taking away that number you just found in the last problem, taking it away from the original price. So those two little equation steps would get you to the answer. Okay?